So next concept is calculation of delta G naught, maximum work and equilibrium constant for Daniell cell. So Daniell cell nothing but zinc and copper cell we can call as a Daniell cell. Zinc and copper cell we can call as a Daniell cell. So we are discussing about that calculation of delta G naught and maximum work and equilibrium constant for Daniell cell. So first delta G naught calculation. Delta G naught is equal to the formula we given minus NF E naught cell. And in the zinc and copper cell, in the Daniell cell, previously we discussed that E naught cell potential is 1.1 volt and the number of electrons change is 2 because zinc converted to Zn plus 2 and the copper, 2 copper plus will be takes electrons and converted to copper. So sorry, copper plus 2 takes electrons and converted to copper. So in the zinc and copper cell or in the Daniell cell, number of electrons change is 2 and the E naught cell potential is 1.1 volt. So these values we have to substitute here. And 1 Faraday of electricity, that is will be equal to 96,500 coulombs. Now we can calculate the delta G naught. Delta G naught is equal to number of electron change is 2 and the sign is what here, minus 2 into 1 Faraday nothing but here 96,500 coulombs and E naught cell is 1.1 volt. And when you calculate these value, delta G naught is equal to, you will get minus 212,300 joules per mole. This is in joules. If we want to convert it to kilojoules, this is, we can write delta G naught is equal to minus 212.3 kilojoule per mole. So this is the delta G naught. Once again, delta G naught, calculation of delta G naught for Daniell cell. So what is the delta G naught formula? Minus NF E naught cell and N nothing but number of electrons change in Daniell cell. How many electrons will be changed in Daniell cell? 2 electrons will be changed. And E naught cell, Daniell cell, E naught cell potential value how much? 1.1 volt experimentally. So 1 Faraday is equal to 96,500 and finally delta G naught is equal to minus 212.3 kilojoules per mole. So after that delta G naught, first one is completed. Next one is maximum work. Next one is maximum work. So maximum work is actually decreasing in the free energy, we call maximum work. Decrease in the free energy. Decrease in the free energy we can call maximum work. Decrease we can show the symbol with negative. So decrease in the free energy nothing but delta G naught at standard condition. So finally here maximum work W is equal to decrease in the free energy. Decrease symbol we can show with minus and free energy standard condition delta G naught. So maximum work is equal to minus delta G naught. And what is the delta G naught value we got here? Minus 212.3. Then from here we can calculate maximum work is equal to minus of minus 212.3 kilojoules. Then it will become 212.3 kilojoules. So you remember that here maximum work is equal to minus delta G naught. It is maximum work is equal to minus delta G naught. In any question, if they given delta G naught and he asked to find maximum work, just you have to multiply with minus. If already minus is there, will be converted to plus. So this is what your maximum work. And the next one is what? Equilibrium constant. How to find the equilibrium constant with respect to delta G naught. Just now we given a relation delta G naught to equilibrium constant, that is delta G naught is equal to minus RT ln K. This equation is given. Relation between what here? Delta G naught and natural logarithm K. Delta G naught is equal to RT ln K. So from here we can find equilibrium constant K. K is what? That you can find. For what? Daniell cell. So now see you. Delta G naught we got the value. That is in, you can take joules because R value are taking in joules. R value what is in joules? 8.314. So we are taking in joules. So delta G naught also you take in joules. Here kilojoules what will be minus 2.2 and joules what it is? Minus 212,300 joules. So delta G naught value take in joules. What will be? Minus 212,300 joules is equal to minus of R value 8.314 joules into temperature standard condition 298 Kelvin and natural logarithm of k. This is. And next one, this natural logarithm, if you convert it to log base 10, also you can convert. So that what will be minus 212,300 joules minus of 8.314 into 298 into natural logarithm. If you convert it to logarithm, that you can multiply with 2.303. 2.303 log base 10 k. From here we can find k. So these values you send here. What will you get? Just you keep the log k here, log base 10 k you keep here, and the remaining send here. That will be minus 212,300 by minus of 8.314 into 298 into 2.303. Anyway, minus and minus will be cancelled. If you calculate this, log base 10k will be get 37. Log base 10k, how much you getting? Log base 10k is 37. From here, what will be the k value? Nothing but it will be 10 power of 37 will come. What's the equilibrium constant value? 10 power of 37. Once again, log base 10k is 37. Then you can calculate k, then you can write 10 power of 37. For example, log base 10k is equal to n. Then what is k? Nothing but 10 power of n will come. In terms 10 power, this value you have to write. So log base 10 k is equal to 37, then k is equal to 10 power of 37. So what it is here? In the Daniell cell, calculation of the delta G naught how much? Minus 212.3 kilojoule per mole. And the maximum work and delta G, what is the relation? Maximum work is equal to minus delta G naught. And equilibrium constant for Daniell cell, how much we got it? 10 power of 37. This is the relation between what here delta G naught and equilibrium constant. And after that, the next one is equilibrium constant from Nernst equation. Equilibrium constant from Nernst equation. Equilibrium constant from Nernst equation. So how to write the equilibrium constant? Same way, similar way. What will be? First you write the Nernst equation. What it is? E cell is equal to E naught cell minus 2.303 RT by NF log base 10 K, otherwise Kc, whatever. K or Kc indicating equilibrium constant only. So now at equilibrium we discussed already, E cell is equal to what? 0. At equilibrium E cell is equal to 0 or Q is equal to what will be K. Better to write Q, no problem here. Then Q is equal to what will be K. At equilibrium E cell is equal to 0 and Q is equal to K, and you substitute here. Then 0 is equal to E naught cell minus 2.303 RT NF log K. We need that what is here? Equilibrium constant K and Nernst equation relation. What you can write from here? E cell is equal to 2.303 RT by NF into log Kc. From here, log Kc is equal to NF E naught cell by 2.303 RT. This is the relation between what? Log Kc and E naught cell. So you have to remember finally what kind of formulas you have to remember here. So once you check that, formulas you have to remember and complete those topics here, what you discuss now. Here, I'm writing the formulas more. First, what formulas you have to remember completely. From the derivation of the Nernst equation from thermochemistry, you remember the first formula, delta G is equal to minus NF E cell. And second formula, delta G naught is equal to minus NF E naught cell. And the third formula, delta G naught is equal to minus RT ln K. Otherwise, we can write this is only R minus 2.303 RT log K also we can write. And the fourth formula you can remember here, maximum work is equal to minus delta G naught. And the fifth one you can find it that log Kc is equal to NF E naught cell by 2.303 RT. This is you can find. So this is the important relations in this session. So how many formulas you have? 5 formulas, but you mostly the questions will be asked in first one, second one, and third one, fourth one.